You may have probably played with magnets in your childhood. These magnets attract and repel each other. Kids love to stick magnets on iron objects and their fridges. Magnets are more than just a toy for playing. Today, magnets play an important role in shaping our modern world. Everybody is somehow dependent on it. Let's find out the amazing information and the facts. What is magnetism? Magnetism is a physical phenomena that arises due to the motion of the charged particles like electrons in the magnets. The moving electrons produce a field around them that is called the magnetic field. This magnetic field is the cause of the magnetic effects that you observe when playing with magnets like attraction and repulsion. The magnets that you have played with are called permanent magnets. These magnets mostly contain iron metals. The iron and a few other metals that can become a magnet or attract towards them are called ferromagnetic materials. You may be thinking how and why electrons move in the iron. The simple answer is that the electrons continuously revolve around the nucleus of atoms. Moreover, electrons also jump from atoms to atoms, which further contributes to the overall motion of the electrons that produce a magnetic field. Now you may be thinking that iron metals has a motion of electrons that produce a magnetic field. Then why every iron object does not have magnetism? To answer this, let's understand the concept of magnetic domain. Magnetic domain. Each atom in the iron materials produce a very small magnetic field due to the motion of electrons. These individual magnetic fields point to the direction according to the orientation of their representative atoms. The orientation of these atoms is random, so it forms regions in the iron objects in which the overall magnetic field of the atom points in the same direction. These regions are called as magnetic domains. You can simply consider each magnetic domain as a region in which all the atoms produce the magnetic field in the same direction. In non-magnetic iron objects, these domains are randomly aligned. As a result, the total magnetic field of the iron object is zero, and it behaves as a non-magnetic object. When all the magnetic domains are aligned in the same direction, then their magnetic fields are added and result in a magnet. Many techniques are used to make an ordinary iron object into a permanent magnet. The simple to do this is to rub a magnet on an iron object in one direction 20 times. This will reorient the magnetic domain to point their magnetic fields in the same direction. As a result, the ordinary iron object will become a magnet. You can also make the screwdriver in your home into a magnet. This will make it easier for you to pick screws. How the magnets attract or repel. Recall your memory that magnets have two poles. One is called the North Pole, whereas the other is called the South Pole. When you bring the South Pole of one magnet near the South Pole of another magnet, they will repel each other. The same is the case when you bring the North Poles together. But when you bring the North Pole of one magnet near the South Pole of another magnet, they will attract each other. The attraction and repulsion effects both are simple as well as complicated to understand. But here we will try to understand them simply. The magnetic field of a magnet has a direction which points from North Pole towards the South Pole. For simplicity, you can consider that the magnet fields start from the North Pole and ends at the South Pole. Let's understand magnetic attraction and repulsion separately. The attraction. The magnetic field that is started from the North Pole must terminate at the South Pole. So when you bring the North Pole of one magnet near to the South Pole of another magnet, they will attract each other, because magnets always try to reduce the gap between their opposite poles so that the magnetic field can complete its path quickly. Magnetic repulsion. The repulsion occurs when the same poles, north-north or south-south, are brought together. It is because the same poles are not completing the path of the magnetic field but disturb its path. So magnets try to repel each other until they are far from each other. Thank you.